Greetings, math fans. All right, so this is the first day of probability, and we already covered counting, and so probability has to do with counting because you have to count how many successes, how many failures, how many total outcomes, all part of probability. So that's why we spent several days in counting, and then we switched into probability. So day one is basically just some simple probability, and we're talking about odds, and we're going to talk about a bunch of different probability things here. So basically the probability of an event is, and this is what you have here, it's P of E. That's how you say it. Probability of an event happening is the number of successes over the total number of outcomes. Okay, so the number of successes is counting the number of ways to succeed. Number of outcomes is counting the total number of possible outcomes. It's pretty easy. A good example is you flip a coin, and success is getting a tail. There's one way to get a tail, so the one's on top, and total outcomes is getting a tail or a head. Two outcomes, right? Two ways to get this. So the probability of getting tails is one tail over two possible outcomes, so the probability is 1/2, which you already knew that, right? If I said what's the probability of getting heads or tails, you would say it's 1/2. But that's just kind of the idea. It's successes over outcomes. Okay, so a couple of notes here. Probability is always between 0 and 1. So when you get your coach saying, "I want you to, I want you to give me 110%," you got to tell your coach, "Coach, it's not possible. I can't give 110% because I can only give 100%. It's the maximum." It's the same thing in probability. Okay, your coach might make you run a few laps, but basically in probability, it can't be over 1 because it can't be more than for sure, and it can't be less than 0 because it can't be less than it's not going to happen. All right. So the probability, when the probability is equal to 0, means certain failure. When the probability is equal to 1, right? So 0 it means certain failure, and 1 means certain success. Now, a couple different things here. One is I can say the probability of success is just equal to 1 minus the probability of failure. So if I know the probability of failure is like 0.2, I can say success is 1 minus 0.2 or 0.8. So it's just the reverse is true with this guy here. If I gave you success, I can find out the probability of failure is 1 minus probability of success. Okay? All right. Let's keep going here. So first example, this is a dice chart. Okay? You're going to see this dice chart a lot. And you guys need to make sure you know how to do a dice chart. Okay, I drew it here for you just to make things a lot faster, go a little more efficiently. But basically, you got 1 through 6 and 1 through 6 top going across horizontally and then vertically. And then you basically just write out, you can see it goes 1, 2, 3, 4, 5, 6, 7. The next line is 2, 3, 4, 5, 6, 7, 8. The next line is 3, 4, 5, 6, 7, 8, 9. And so you all go down to the bottom line is 6, 7, 8, 9, 10, 11, 12. So it's actually pretty fast to draw out a dice chart. Okay. Anyway, we're rolling 2 standard dice and find the probability of a sum of 7. So basically what you're doing is this is the sum. So when I say a dice chart, this is the sum. So in other words, if I roll a 1 and a 1, here's the 1 right here and a 1 right here, I get a 2. Okay? If I say what's the probability of getting a sum of 7, so let's clear some of this out here, I get 1, 2, 3, 4, 5. There's 6 ways to do it. And how many? So it's 6 successes. And how many total outcomes do I have? Well, it's 6 times 6, which is 36. So 6 out of 36, which is 1/6. Okay, that's the probability of getting a sum of 7. The sum of 1. Well, there is no sum of 1 because you can only roll a 1 and a 1. The maximum or minimum value is 2, right? So you can't roll a sum of 1. So it's certain failure. That means you're going to put a 0 here. Okay, what's the probability of getting a sum greater than 3? Well, I could add up the 4s, and I could add up the 5s, and I could add up the 6s and 7s and 8s, 9s, 10, 11, 12. But remember, probability, I can just say 1, so the probability of getting a sum less or greater than 3 is 1 minus the probability of a sum less than or equal to 3, right? Because less than or equal to 3 is failure. So as opposed to counting all those up, why don't I just do 1 minus, And basically it would be 1 minus less than or equal to 3. So it would be this one, and this one. So there's just 3 of them there. So it's 1 minus 3 over 36. Okay, which gives me 33 over 36. And I always want you to use your calculator. So you're always going to use that nice little fraction button in your calculator. Basically hit math, enter, enter. Always math, enter, enter. And so you get 11 over 22. Okay, not bad. Number 2, on a trick die, the face that ordinarily bears a 1 has a 6 painted on it instead. The other faces are unchanged. If the die is rolled once, what is the probability of rolling an even number? So I'm only rolling 1 die now, so I'm not using this dice chart, but this is what I basically have. Instead of having a 1, 2, 3, 4, 5, 6, I have, instead of the 1, it's a 6, 2, 3, 4, 5, and 6. So there's no 1. It's a 6 instead. So what's the probability of rolling an even number? Well, how many even numbers are there? There's 1, 2, 3, or 4 of them, right? And how many total outcomes are there? Again, 6. So the probability is 2/3. Okay? Probability of rolling a number less than 4. Well, less than 4 means 2, 3, and that's it, right? So it's 2 out of 6, which is 1/3. Okay, so that's simple probability. Successes over outcomes. Let's do a couple problems now with cards, because we're going to be doing a lot of stuff with cards. There are 52 decks, or 52 cards in a deck. Just to kind of review things a little bit, if you don't know much about cards, I'm not asking you guys to be a professional poker player here, but I'm asking you guys to understand in a deck there are 26 red cards. Half of them are red, half of them are black. So it's 26 red cards. Out of those 26 red cards, 13 are hearts, 13 are diamonds, right? So it's basically a quarter of all the cards are hearts, a quarter of all of them are diamonds, and then in the black cards you have 13 spades and 13 clubs. So a quarter are spades and a quarter are clubs. Basically, let's move over here to 13 ranks. A rank is, just think of a rank, like a jack and a queen and a king. That's like a rank in an army, right? Or a rank in royalty. So rank is actually that number, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. That's a rank. So 13 ranks. Each rank has 4 suits. So in other words, my example I have here, you have a 2 of hearts, a 2 of diamonds, a 2 of spades, and 2 of clubs. Okay, so all of them have hearts, diamonds, spades, and clubs. Okay, a face card. A face card is a jack, a queen, or a king. Nothing else. It's not an ace, so please don't come up and ask me, Mr. Kervis, is an ace a face card, because I'm going to say go sit down. There's no face on there, except maybe the spade one has a face. But in general, there's no face on any cards except for a jack, a queen, a king. Okay, just think about it. Those are the only ones. Those are like people, right? They have faces. So jacks have faces, queens have faces, and kings. So there are 12 of them, because there are 4 jacks, jack of hearts, diamonds, spades, and clubs, and then a queen of each of those and a king of each of those. So there are 12 face cards total. Got to know those things. Memorize this. It's not that difficult. And someday maybe you'll be a professional poker player. I don't know. And then you can give me some of your winnings. Okay. So let's look at a question here. Suppose that a card is drawn from a standard deck of 52 playing cards. What is the probability of drawing an ace? Well, how many aces are there? There are 4 aces out of 52. And you reduce that to 1 over 13. Pretty easy. What's the probability of a queen of spades? There's only 1 queen of spades, so it's 1 out of 52. What's the probability of a red card? Well, I could do 26 out of 52, right? That's okay. Or just note half of them are red and half of them are black, so the probability is 1/2. A black face card. So now, right, how many black face cards are there? Well, do you guys agree there's the jack, the queen, and the king, and each of those have 2, right? A spade and a club for each of them. So there are 6 out of 52, which gives me 3 over 26. Okay? Not bad. So that is basically talking about dice and talking about cards with simple probability. Okay, so let's move on to just another topic here. It's called odds. The odds of an event a little bit different than probability. Probability was success over failure, or success over total. Odds is success over failure. Okay, it's really important. It's successes over failures. Very, very important. Okay, so it's somewhat related, just instead of total outcomes on the bottom, it's failures. That's we're comparing successes and failures. So just kind of using an example I used in the beginning, you flip a coin. A success is getting a tails. There's one way to get a tails. A failure is getting a heads. So there's one way to get a heads. So the odds are one tail or one heads, which equals 1 over 1. So there's kind of three ways you can write this. You can write this as a fraction here, or you can write it with colons, right? You say a 1 to 1, or actually write 1 to 1. Okay? But odds, you always need some sort of fraction, you need something. Please don't tell me the odds are 1. That really doesn't say anything because you're kind of looking for some comparison between things. So don't reduce a fraction and go, oh, well, gee, the answer is 5. Well, no, 5 to 1. You need to tell me that, okay? All right, so let's take a look at number 1 here. A bag contains 3 red, 5 blue, and 2 green pens. You randomly choose one pen. What are the odds that the pen is red? So remember what you're going to do is you're going to say, how many successes do I have? So I'm going to say success is 3. That's a red pen. And how many failures? Well, failures are the other 2, so it's 5 plus 2 is 7. So my odds are successes over failures, so 3 sevens. Okay. What are the odds that the pen is blue? So again, 5. My success is 5 blue, and my failure is the rest of them, which is 5. So my odds are 1 to 1. Okay, what are the odds that the pen is green or blue? Well, success is green or blue, so it's 5 plus 2, which is 7. And failure is red, which is 3. So odds are successes over failures, so 7/3. Okay, now that obviously can't be a probability because you can't have probabilities greater than 1. Odds you can. Okay, because success over failure can be anything. All right, so comparing probability and odds. To understand the difference between probability and odds, let's take a look at the sum of 2 dice rolled. So again, here's our nice dice chart. Again, this is our sum, right? So just kind of be aware of that. The probability of getting a sum of 9. Well, let's count the number 9s. 1, 2, 3, 4. There are 4 9s. So it's 4 out of 36, which is 1/9. That was easy. What are the odds of getting a sum of 9? Well, again, success is 4. Failure, isn't it just 36 minus 4, which is 32? That's failure. You're going to fail 32 times. So it's 4 over 32, which reduces to 1/8. So those are the odds of getting a sum of 9. So you can see probability and odds, they're a little bit different, right? Let's look at number 3. If you roll a single die, what is the probability of getting a 4? Well, isn't it 1/6? Because it's a 6-sided die, right? What are the odds of getting a 4? Well, again, there's 1 4. That's my success. And how many ways of not getting a 4? 5 of them, right? That's my failure. So the odds are 1/5. So now what I can do is I can give you stuff about odds and you got to give me probability, or I can give you things about probability and you got to give me odds. So this first question, or number 4, says if the odds of an event are 3 sevenths, so what you want to do is you want to label things. If those are odds, that means that's success and that's failure. So my total outcomes is 3 plus 7, which is 10. So when I want to find out the probability, it's just 3 successes over 10 outcomes. Okay? Now if I give you the probability of an event and I ask you for the odds, well, again, think what it is. Number 5 is success and 11 is total outcomes. So what I want to do is, to get me my failure, I basically do the total minus the success, which of course is going to give me failure. And then when I ask you for the odds, it's success over failure, so it's 5 over 6. Okay? Not too bad. Not too bad. All right, so the last topic here, I put a big bold box on top here because the key word for the following problems is or. Okay, so it's basically you're going to talk about a single event, a single pick, a single roll of a die, so pick of a card, etc. Okay, we're going to talk about two different things here. It's something called mutually exclusive events, events that cannot happen at the same time. So the probability here, write this guy right here, the probability of A or B, I just add the probabilities together. Those are mutually exclusive. They can't happen at the same time. So an example is you choose a king or a queen in one selection. Okay, you can't pick a king queen. Doesn't make sense. So you would add those probabilities together. Another example is choose a sophomore or a senior in one selection. Okay, there's no overlap. You don't have a sophomore senior, okay, or a senior sophomore. So they're completely independent events. We call them mutually exclusive. Exclusive means they're kind of separate. Okay, if you go to an exclusive club, you're kind of separated from all the uncool people, I guess. I don't know, whatever. All right, so let's take a look at the first example here. A pair of dice is rolled. What is the probability that the sum is a 3 or an 8? 3 and 8 are completely different numbers. There's no overlap at all. So I look at the probability of getting a 3, and there's two of them, right? 1, 2. So it's 2 out of 36. And then the probability of getting an 8 is 1, 2, 3, 4, 5. So 5 out of 36. So the probability is 7 over 36, and can't reduce that. All right. What is the probability that the sum is an odd number or an 8 or 10? Again, an odd number is not an 8 or 10, so there's no overlap. They're completely separate events. And let's think about it. What's the probability of getting an odd number? I mean, I can add the 3s and the 5s and the 7s and the 9s and the 11s. Aren't half of them odd and half of them even when you roll two dice? Okay, you can count them, but if you know half of them are odd, half are even, so I would say basically an odd number is 1/2, and then the probability of getting an 8, we already did that one, that's 5 over 36, and probability of getting a 10 is 1, 2, 3, plus 3 out of 36. No overlap at all. And I add all those together, and I get 13 over 18. Okay? Number 2. In a deck of playing cards, what is the probability of drawing a face or a 7? And notice, math fans, I said the key word on top. Let me go back to the top. The key word was or. That's so huge right here. Okay, it's a single event. So here it is. I rolled a pair of dice. It's one event that I rolled. Okay, a deck of playing cards. I'm picking one card. That's all. And so I said, and here's the word or right there. So or. Okay, so what's the probability of picking a face card? Well, isn't there 4 jacks, 4 queens, and 4 kings? So it's 12 out of 52. And a 7. How many 7s are there? There's 4 of them, right? So or means add. Very, very important. Or means add. So I get 16 out of 52, which is 4 over 13. Okay, what's the probability of getting a red card or a black jack? Again, completely separate events, no overlap at all. Probability of getting a red card, half of them are red. Okay, a black jack, there are only 2 black jacks, the jack of clubs and the jack of spades. So 2 out of 52. And so our answer for this one is 7 over 13. Okay, not bad. Number 3, if the probability of Jack picking a red pen is 0.2 and the probability of him picking a blue pen is 0.4, then what is the probability of Jack picking a red or blue pen in one pick? Well, again, they're completely independent events, so you literally just add those together. So it's 0.2 plus 0.4, so we get 0.6. Really, really easy. All right, so the next part here, we talked about mutually exclusive. Now we're talking about mutually inclusive events, events that can happen at the same time. Okay? So what we're doing is we're saying the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And basically, here's the deal. Sometimes you're going to, if I said the probability of A and the probability of B, sometimes a certain event is going to be counted 2 times, one in A and one in B, and so you don't want to count it twice, you want to subtract the overlap. The best example here, math fans, is you choose a king or a diamond in one selection. Okay, if I say what's the probability of picking a king, and then the probability of picking a diamond, I've counted the king of diamonds the first time, and I've counted the king of diamonds the second time. I don't want to count it twice, so you subtract the overlap. So you subtract basically the probability of getting a king of diamonds. The next one is you choose a blue-eyed person or a male. The overlap is a guy with blue eyes, because if you count the blue-eyed people and you count all the males, you're counting the blue-eyed males twice, and you got to subtract the overlap. Okay? So let's take a look at number 4 here. In rolling a pair of dice, again I drew a nice dice chart for you. What is the probability that the sum is divisible by 2 or 3? So let's just kind of write this out here, because I think that's kind of important. If it's divisible by 2, do you guys agree it's either going to be a 2, 4, 6, 8, 10, or 12? And if it's divisible by 3, it's going to be a 3, 6, 9, and 12. Well, here's our overlap, math fans. The 6's are counted twice, and the 12's are counted twice. And I don't want to count those twice. Okay? So, let's count, the number's divisible by 2, so let's do the probability here. Divisible by 2, do you guys agree that half of them are divisible by 2? Because it's kind of like saying the even numbers. I mean, I can count them all, and I would get 18 out of 36 if I count them all. Or I know it's 1/2. So I'm doing basically the probability of a 2 plus the probability of divisible by 3 minus the probability of 2 and 3. Oops, 2 and 3. That's my overlap. So probability of getting a 2 is 1/2. The probability of getting a 3, well, 3, 6, 9, 12. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you guys agree with that? 12 out of 36. And then how many overlaps? Well, the 6's and the 12's are counted twice. So the 6's and the 12's are counted twice. So I need to subtract 6 out of 36. That's the overlap. And my answer comes out to be 2/3. Okay, so letter B says a 7 or exactly 1 die shows a 3. So basically what we're doing the probability of getting a 7 plus the probability of 1 die getting, showing a 3. So the probability of getting a 7 is 1, 2, 3, 4, 5, 6. So it's 6 out of 36. Probability of exactly 1 die, so let's circle that. 1 die getting a 3, so it's this one, not this one, because that would be 2 dice getting a 3. That one, 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 and that one. All right. So if I count all those, I get all the red circles. I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's plus 10 out of 36. And then what's the overlap? Well, it's where the black and the red are both circled together. So it's, let me highlight this guy. It's this guy right here and this guy right here. 2 of them, right? 2 places where they're both highlighted. So it's minus 2 out of 36. Okay? And that gives us, with our fraction button, 7 over 18. Okay? Not bad. Not bad. Number 5, in a deck of playing cards, what is the probability of drawing a red card or a jack? So what's the probability of getting a red card? Well, half of them are red. What's the probability of getting a jack? There are 4 out of 52, or 1 out of 13, either way you want to do it. But now you got to think of the overlap. There's a red, how many red jacks are there? Well, there's a jack of diamonds and a jack of hearts. So there's 2 red jacks. So I counted the red jacks here, I counted the red jacks here. So I got to subtract one of those. And if I do that, I get 7 over 13. Okay, a spade or a face card. Well, how many spades are there? Aren't 1/4 of them spades? How many face cards? Well, it's right, 4 jacks, 4 queens, and 4 kings. So it's 12 out of 52. And now what's kind of overlap? Well, how many face cards have a spade? Well, doesn't jack and a queen and a king have a spade? So aren't there 3 out of 52 where we counted them twice? Okay, so we do that and we get 11 out of 26. Okay, number 6, the probability that a student excels in math is 7 over 24. The probability that a student excels in science is 1/4. If the probability that a student excels in both math and science is 1/12, determine the probability that the student excels in math or science. So this is kind of it's an easy problem because the probability of excelling in math is 7 over 24. The probability of excelling in science is 1/4. But then you have the probability that you excel in both math and science is 1/12. Well, here's the deal. I counted the people in this group that were smart in science too, and I counted the people in this group that were smart in math. So this is the overlap right here. And so what you're going to do is you're going to say 7 over 24 plus 1/4 minus 1/12. And you get 11 over 24. Okay? So that's basically the end of the lesson here, math fans. We learned a little bit about basic probability and about odds. And then we switched to basically talking about mutually exclusive, which means events can't happen at the same time, which means you just add the probabilities together, look for the word or. And then we have mutually inclusive where events can happen at the same time and you have to subtract that overlap. So always look for that. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.